In this lecture, we want to move into section 4.3 and talk about area and definite integrals. So in previous section, in section 4.3, or in section 4.2, excuse me, we looked at what was called indefinite integrals. So indefinite integrals look something like this. The integral of f of x dx, and what we saw was this was equal to capital F of x plus c, some constant of integration. So definite integrals are a little bit different, and what's going to happen is you're going to have these things called bounds of integration, and you'll see that in the coming slides. So we're going to relate definite integrals to area. So it turns out to find the area under the graph of a non-negative continuous function f over some interval a to b, the way you would find that area, the first thing you would do is you'd find the antiderivative of the function. Okay, so you'd find the capital F of x. So to go back, you'd find this. And then what you do is you'd evaluate the antiderivative f of x at the two endpoints of the interval. Okay, at x is equal to b and x is equal to a. And then what you would compute is f of b minus f of a. This result right here, and I'm going to show this to you by working an example from the previous section, just to prove it. The result is the area under the graph over the interval from a to b. So this gives us the following definition. Okay, and this is the definition of a definite integral. Let's let f be a continuous function over the interval from a to b. And let's let capital F be any antiderivative of f. Then the definite integral of f from a to b is given as the following. So you're going to integrate from, and these right here are called the bounds of integration. So you're going to integrate from a to b, f of x dx is equal to, and this is going to be f of b minus f of a. And again, this right here is the area under the curve between a and b. Okay, just a few things here. One, when you compute definite integrals, you no longer have c. Okay, that constant of integration. Okay, it goes away. All right, because if you think about it, really, you'd have f of x plus c minus f of x, and then you distribute the negative to the plus c minus c. The c's would cancel. In 2, this integral, when you solve these, they can be less than 0. Okay, I know what you're saying. Like, well, this f of b minus f of a is supposed to be area. How can area be negative? What this means is, if you were to sketch the graph, let's say some function that looked like this, okay, and you wanted to find the integral from a to b, here's a and here's b. Do you notice how most of the area of this graph, if you're looking at it bounded between the graph and the x-axis, falls below the x-axis for negative y values? That just means the majority of the graph falls below the x-axis. That's okay. So if you solve these definite integrals, you can get an answer less than 0. Totally okay. Not an issue. All right. So does this work? So recall this integral. Okay, this was from the previous slide or previous section. The way I showed you how to do this is solve with geometry. And what you did was you sketched this graph and it looked like this. You'd say, okay, I want to find 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is my function f of x. It's just a horizontal line from 0 to 5 here because I want to go from 0 to 5. And this area under the curve here, this area was just the area of a square, which ended up just being 5 squared, which is 25. So now what I want to show you is how to solve this using this definition right here. Okay, well, what's the antiderivative of 5? So if you were to integrate this, you'd get 5x, and you're going to see me write it like this. So I'm going to evaluate this from 0 to 5. So what this means is you're going to take the top bound and plug it in. So plug 5 in for x, you get 5 times 5. Minus, going back, you're going to take the bottom bound, a, and plug it into the function. So 5 times 0. So this is 25 minus 0. You get the same thing, same result. And that's what you would expect doing this. Okay, so you no longer have to use geometry to find this area. All right, so all I want to do now in the remainder of this lecture is show you how to do a bunch more examples of this, and then do 2 economic examples. Okay, so here's the first one. Let's find the area of the graph of y is equal to x squared plus 1 over the interval, area under the graph of, over the interval from -1 to 2. So first off, let me just show you what this graph is going to look like. One, two, three, 1, 2, 3, 1, 2, 3, 4. So when you plug in -1, right, you get -1 squared plus 1, you get 2. I'm sorry. When you plug in a 0, you get 1. When you plug in 1, you get 2. When you plug in 2, you actually get 5. So the graph looks like this. So we want to find the area, this red shaded area here. So this area is equal to, you're going to integrate from -1 to 2, x squared plus 1 dx. Well, when you integrate x squared, you get x cubed over 3. When you integrate x, you get x. So now what you're going to do is you're going to plug in the top bound. So you're going to get 2 cubed over 3, plus when I plug the 2 in here, minus, and then in parentheses I'm going to plug in the -1. So you're going to get -1 cubed over 3, okay? And then plug the -1 in here, so -1. So 2 cubed is 8, so I get 8/3 plus 2. -1 cubed is -1, but then minus, so plus 1/3. Minus becomes plus 1. Well, look, 8/3 plus 1/3 gets 9/3. 2 plus 1 gets me 3. This is just 3 plus 3. So this area here is equal to 6. So that's how you do this. Let's just quickly do a bunch more examples just so you can, again, continue to see the process. All right, so let's evaluate each of these. So we're going to evaluate the integral from -1 to 4 of x squared minus x. Well, when you integrate x squared, you get x cubed over 3. Minus, when you integrate x, you get x squared over 2. And then I'm evaluating from -1 to 4. Okay, so I'm going to plug 4 in. So I get 4 cubed over 3 minus 4 squared over 2. Minus, and then I'm going to plug in -1. I get -1 cubed over 3 minus -1 squared over 2. Well, 4 times 4 is 16. 16 times 4 gets me 64 over 3 minus 16 over 2. Again, minus 1 cubed is -1, and then minus again. So it gets me plus 1/3. And then this is -1 squared is 1/2 minus, so plus 1/2. So this ends up getting me 64 plus 1 gets me 65 over 3. And then over here you get 16 plus 1, you get minus 15 over 2. And I'm just going to leave it like that for you without finding common denominators here. And then again here, well, when you integrate e to the x, you just get e to the x evaluated from 0 to 3. So just plug in the 3. This is e to the third power minus plug in the 0, e to the 0, which is e to the third power minus 1. Let's try this one here. So we'll evaluate each of the following here now. This is, we did A, B, now let's do this one. So you just have to go through, integrate. When you integrate a constant, you just get 1 times x, which is just x. Here you're going to get 2 over 2, which cancels with this, so plus x squared. And what is the integral of 1 over x? Well, that's the natural log of x. And I'm going from 1 to e. So plug in e now. So you get e plus e squared minus the natural log of e minus, now plug in 1. 1 plus 1 squared minus the natural log of 1. Okay, well let's clean this up a little bit. This is e plus e squared. Well, what's the natural log of e? Well, that's just 1. Minus, okay, 1 plus 1 here just gets me 2. And the natural log of 1 is 0. So you end up just getting e plus e squared minus 1 minus 2 minus 3. Just like that. All right, some more, just so we get the whole concept down. Okay, this one here. Let's go and integrate this. So this, you're going to take, I'll even slow this one down a little bit. You get 3 plus 1 is 4 over 4 minus 3 x squared over 2, right, when you integrate that. Evaluated from 2 to 4. Well, what does this here get you? Okay, the 2 and the 4, you end up getting x to the 4th over 2 minus 3x squared over 2. Like so. And then you're just literally gonna plug it in. This becomes 4 to the 4th power over 2 minus 3 times 4 squared over 2 minus, and then I'm going to plug the 2 in, 2 squared over 2 minus 3 times 2 squared over 2. And I'll let you simplify from here. I won't waste time with the algebra or the arithmetic. Okay, here, the constant doesn't matter, so you can even write this as 2 times the integral from 0 to the natural log of 4 e to the x dx. Well, what does e to the x integrate as? Well, this is just 2 e to the x, evaluating from 0 to the natural log of 4. So plug it in. You get 2 e to the natural log of 4 minus 2e to the 0. Well, e to the natural log of 4 ends up just being 4. So this is 2 times 4 minus 2 times 1. So this is 8 minus 2. Just gets you 6. Okay, to do this one here, what you would do is you'd actually break it up. So the integral from 1 to 5 of x minus 1 over x. So what you would do is you'd write this as x over x minus 1 over x dx. Well, x over x simplifies to 1 minus 1 over x dx. And when you integrate that, right, 1 integrates as x, 1 over x integrates as the natural log of x, and you're going from 1 to 5. So this is just 5 minus the natural log of 5 minus 1 minus the natural log of 1. Well, what's the natural log of 1? Well, that's 0. So you get 5 minus 1. You get 4 minus the natural log of 5. So again, what you're just doing in all these, you're just following the rules of integration, and then you're just plugging in the top bound and then plugging in the bottom bound and finding their difference. And that's it. All right, I just want to walk through 2 quick economic examples now for you. Okay, so here's the first one. Suppose that you have this value y, okay? And y is the profit per mile traveled, and x is the number of miles traveled in thousands, okay? So it's just maybe it's some car service or some transportation service. So let's find the area under this equation, y is equal to 1 over x over the interval 1 to 4, and interpret the significance of the area. Okay, well that's pretty straightforward. You know, it's the integral from 1 over 4. This is, you can rewrite this as 1 over x dx. Well, we know that integrates as the natural log of x. And again, you just plug in the bounds, right? So this becomes the natural log of 4 minus the natural log of 1. Well, we know the natural log of 1 is 0. So what's the natural log of 4? This is just roughly 1.3863. And so x is in thousands of miles, okay? So you would take this result and multiply it by 1,000. And what this area here under the curve represents, this area represents a total profit, okay? When miles traveled increases from 1,000 to 4,000 miles. So this area under the profit curve tells us what the total profit is. All right, when you go from 1,000 to 4,000 here, or when x is equal 1 to 4. Okay, here's the last problem. So Northeast Airlines determines that the marginal profit, okay, so we know that this is a derivative when you hear the word marginal. If p of x is the profit function, p prime of x is the marginal profit. All right, so the margin resulting from the sale of X seats on a jet traveling from Atlanta to Kansas City in hundreds of dollars. So, you know, if you got a result of 1, that would be $100. So the marginal profit is given by this. P prime of x is equal to the square root of x minus 6. So let's find the total profit when 60 seats are sold. So the way you could do that, what you really need to do is you need to find P of 60. Okay, but you don't know what P of x is, right? You're given P prime of x. So how can you find P of x? You integrate P prime of x. So then P of 60 here will actually, you could actually do it as the indefinite integral from 0 to 60 here of P prime of x. Okay, it's the same thing. Now, if you didn't have 0 here, if you put like 1 or 2 or something, it wouldn't be P of 60. That's really important, okay? 0 here, because when you plug in the 0 bounds, well, what's the profit when you sell 0 units? 0, so it's going to go away, which is why you do that. So you're going to integrate from 0 to 60, square root of x minus 6. So what you're going to do here is square root of x you're going to write as x to the 1/2 power. So when you integrate this, right, you get x to the 1/2 plus 1 divided by 1/2 plus 1, which is x to the 3/2 over 3/2, which is 2/3 x to the 3/2. And that's what you see right here. So, and then when you integrate 6, you just get 6x. So when you plug in the bounds of integration now, okay, from 0 to 60 here, okay, you plug in the 60 in for x, you plug in the 0, and then you do minus, you plug in 0 for x, you end up getting this value here, just to save a little time. You end up getting minus 50.1613. Now remember, this result is now in hundreds of dollars. So when 60 seats are sold, Northeast profit is minus $5,016.13, because you would take this number and multiply it by 100. Okay, so that is if the airline only sells 60 seats, they're going to lose a little over $5,000 on the flight, which isn't good. Which is why when airlines fly us, you know, from destination to destination, they like to pack us into the plane like sardines.